In SQL Server, you can have one clustered index on the table because there's only one way how you can physically sort the data in the table, but you can have multiple non-clustered indexes. And just because you can have many non-clustered indexes does not mean that you should create so many non-clustered indexes. Sometimes we get tempted to create non-clustered indexes because they can really help improve query performance. And when we continue to do that, we kind of land up having many non-clustered indexes on just one single table or a collection of tables. While non-clustered indexes can help improve performance of your select queries, they can really degrade the performance of inserts, updates, and deletes. Now, this is something that is widely known. I thought, why not record a simple demo just to prove this point? But why does non-clustered index degrade this CUD operation performance? When I say CUD, I mean from the CRUD operations, R is read, but then you have create, update, and delete. Because when you create non-clustered indexes on specific column or columns, and when you're inserting data or you're deleting, the data needs to be deleted from the non-clustered indexes also. And when you're firing your update statements, and if they're touching those columns on which you have indexes, then those indexes need to be updated. And that would degrade performance. So it's like you need to strike a right balance of having non-clustered indexes. So you're not degrading the insert, update, and delete performance, yet you're helping the select queries. Now, a lot of talking done. Let's jump over to the demo. Again, as always, I'm using AdventureWorks 2016 for the purpose of this demo. We have a table here called sales order detail. I'm going to make two copies of this table, SOD1 and SOD2. Let's do that and execute. And it may just take a second. Yes, done. So you have about 1.21 lakh records, 121K in both the tables. Now let's go and look into the index structure for these tables. Let's do the first one, SOD1, and you can see the object SOD1 does not have any indexes. We just created these tables, so they are heaps right now. And likewise for SOD2 also, we do not have any indexes. Make sure actual execution plan is turned on. I'm not turning it on right now, but I will turn on set statistics time. Done. These are some helper queries, so let's just get over them. Now, what we are going to do, we have two copies of this table, SOD1 and SOD2. SOD1 is going to be a heap, and we are not going to create any index on it. And SOD2, we are going to create multiple non-clustered indexes. Well, in this example, I could have created clustered index, and the metrics, the performance numbers that we are going to see will not matter much. So I've skipped the clustered index portion. I'm only creating additional non-clustered indexes on SOD2. So I create the first non-clustered index on line total column. Then I create another one on modified date. This is the second non-clustered index. Then we are creating another non-clustered index on product ID. And then we are creating the fourth non-clustered index on line total and modified date, composite non-clustered indexes. I'm smiling because this is what we do, right? For every select query, and we want to improve the performance because some of these columns could be in predicates. We land up creating so many non-clustered indexes. So now the setup is done. We have two tables here, exactly identical. We have SOD1 and SOD2. SOD2 has 4 non-clustered indexes that do not exist in SOD1. Now it's time to insert data, or rather perform an insert operation into SOD1, and we're going to look into execution plan and record performance time. Well, the demo is very simple, just to prove that point that we talked about. So let's go and turn on actual execution plan, and time statistics is already on. So we have an identity attribute here. So let's go and set this identity insert to turn on, because we are manually going to insert into this column. Let's go and execute this. And now we are going to insert data into SOD1. So what I'm doing is I'm just selecting whatever is there in SOD1 and inserting it back again into the table. Let's do that. And these are the respective columns in the table. Okay, let's go and execute. And how much time this has taken? So this has taken, if you scroll down, just about a second or so to execute, and similarly about a second CPU time. And if you jump over to the execution plan, very straightforward execution plan, right? You're scanning the table because you want to read that data, and then it gets inserted back to the same table. Very straightforward. Now comes the fun part. Just to remind you, in SOD2, we have 4 non-clustered indexes, and that should show up now. There you go. These are the ones that we created. Okay. Now what I need to do is, for SOD1, I need to turn off this identity insert and turn it on for SOD2. And we've done that. And now let's go and execute this. And this is going to be fun. So remember, there are 4 non-clustered indexes here. So when you're inserting data, even those non-clustered indexes need to be updated, which means the respective column values will go into those non-clustered indexes, which is going to take additional time. And this will hurt the insert performance here. So let's go and execute this. And let's see how much time this is taking, running. And now you can clearly see that your insert performance is affected. Let's scroll down and see, wow, this has taken more than 5 seconds overall CPU time and elapsed time, more than 5 seconds, close to 6 seconds to execute. And if you jump over to the execution plan here, again, quite self-explanatory, which is you scan the table SOD2 and you are inserting data into SOD2 table, but you're also updating the 4 non-clustered indexes. This is what you can see in the execution plan clearly. So this kind of age-old theory, and of course a proven thing, that if you have many non-clustered indexes, your insert, update and delete performance may go really bad. Crude database operations, right? Create, read, update and delete, out of which CUD will get affected. So when you are creating your next non-clustered index, be careful, be judicious, always balance this out, the select performance versus the insert, update and delete performance. Happy SQL. If you like the content, give it a thumbs up, subscribe to the channel and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there: video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.